Alright guys, so this is the board in the 10 kilowatt system I was talking about. This board is referred to as a DC-DC converter. Actually what it does is it converts the DC bidirectional, either from high voltage DC to low voltage DC or from low voltage DC to high voltage DC. Now I'm going to break this board down into sections. Here we have the bus bar. That's the bus bar for battery. That's a battery bus bar that takes in the low voltage from the battery. So these are the capacitors for the low voltage bar. And then to the right, or sorry, to the left, you have this set of converters from here. Here is a H bridge that drives this transformer. And this transformer in turn will produce a high voltage 320 volts, and that will be supplied to these capacitors. Similar thing happens here, and this is the output from here. So now this board is driven by another board, a more bigger control board. But before that, this is where the control board comes into this particular driving signals comes in here. And then what you have here are the IGBTs, if you like, you call it MOSFETs, that will later convert or rectify the output power from this, and then it's stored on this capacitors. Yeah, they are all here. What you have here, this operizer card, is actually a driver circuitry. Yeah, that is used to drive the individual MOSFETs or the IGBTs, as the case may be. These are small current transformers, and this is a filter. Yeah, these are filters. These are filters. Same thing here. So basically, this is what you have in this system. Now, these two sides are identical. This is identical to this. So if you come down here, it's a similar design that they have in the 5 kVA systems, where you have this SG 3425, I guess. You can enable the signal in this side to be able to have an output to confirm that this IGBTs or this MOSFET here, these are MOSFET, is actually working. And this MOSFET has its own driver card here. Usually when it fails, the way to notice that it's failed is to look at the card. If it's brownish, if it is brownish, then the board is gone. You have to either do a repair or you do a replacement. And here is a power supply port to supply power to an external load, like another board here, or maybe the control board that will power this up. And like I said, these two are identical. This is the PWM IC. These are the totem pole transistors, and these are connected to this, which when this is driving is going to pulse these small pulse transformers. Same thing is happening here. So this is connected to these IGBTs, while this is connected to these MOSFETs. The same thing happens here. This is where the driving signal comes into this side. This is where the driving signal comes into this side. So if it fails, it's easy to repair. These are the things to check out for. You check this card, remove this card or replace it. If you remove this card, you see the bonds components, replace the components. Secondly, look at all these IGBTs, or this MOSFET rather. Check all the MOSFETs and replace the ones that are bad. Do the same to this side. Also, you should check these IGBTs. Most times, if this MOSFET should fail, these IGBTs are also bad. So you check and replace them accordingly. Once you've done that, also read the values of these guys. Be sure that they are not bad equally. And once you've done that, you need to verify this board before you install it back in your unit. So the easier way to verify this board is by connecting battery to this, and then you should short this pin. These two pins, short them together. This is connected to this PWM generator. If you short that, it will enable this chip to generate the necessary voltage to drive this. When this is driven, this will go high and the output will be rectified and stored here. Once that is done, you will be able to have a 320 volts grazing at that point. If that's available, then you successfully repaired the board. Other faults may come, yes, it's just for you to take it one after the other and fix it. But the major one is fault O3, which in order to repair that fault O3, that is what you do. Sometimes this card can fail. If this card fails, these components here are gonna go bad. They were gonna blow up. I don't know if this is blown. Okay, this one is not blown. This one is not blown. It's still okay. Yes. This one is still okay. This particular board is still functioning well. So if it is blown, you will notice it. So guys, thanks for being there. If the video is helpful and useful, give me a thumbs up and subscribe to my channel. See you guys some other time. Have a nice day.